in the introduction of complex numbers. So to start, let's look at a quadratic. We're asked to solve this using any method. There's a b term, so square roots is out. I'd probably use the quadratic formula. So let's make sure I have my pen here. Let's identify my a as 1, my b as 2, and my c as 2. Plug everything in. The quadratic formula tells me that x equals the opposite of b plus or minus the square root of my b squared minus 4 times a times c all over 2 times my a term. So that's negative 2 plus or minus the square root of 2 squared is 4 minus 4 times 1 times 2, 8 all over 2. Negative 2 plus or minus the square root of negative 4 over 2. At this point, we recognize that we have a negative square root, and we know that there are no real solutions, but this video is intended to give us a strategy. From here, we'll use what are called complex numbers. So let's get started. Today we're talking about complex numbers. First, we're going to introduce the imaginary number. At some point, we will graph them, probably not on today's presentation. And then we'll also have to learn to add, subtract, multiply, and actually divide complex numbers, but that won't be part of this presentation. So if we have the square root of a negative number, we need to figure out a way of dealing with it. And mathematicians a while back recognized something called the imaginary number, and it's written as I, lowercase I, usually in italics, and it's defined as the square root of negative 1. So for any real positive number a, the square root of negative a is I times the square root of a. So we use I to essentially pull out the negative portion of our square root. It's also defined as I squared equals negative 1, and that will help us when we get into our arithmetic with complex numbers. So for example, if we had the square root of negative 8, rather than just throwing in the towel and saying no real solutions, we can now treat it as negative 1 times 2 times 2 times 2, and the negative 1 can come out as I, and the two 2's will come out, leaving us with 2i on the outside, and that radical 2, that 2 didn't have a partner to come out, so he stays in. Some other examples. Square root of negative 3. If you want to pause the video and try these at any time, feel free. That's I radical 3, so the negative just came out as an I. 3 couldn't be reduced any further. Negative radical 12, well, that can be reduced as 2i radical 3. Negative radical 36, that's just 6i. So some quadratic equations have solutions that are complex. Those are the ones that have negative square roots along the way. For instance, 4x squared plus 100 equals 0. I recognize that this does not have a b term, or b equals 0, so I can do this most efficiently by using the square root method. I would subtract 100 from both sides, divide by 4, and get x squared is negative 25. So the square root of negative 25 is plus or minus square root of negative 25. That can be written as plus or minus 5 times I. Here are some other examples. 3x squared plus 27 equals 0. Again, I would use square roots. So I'm going to subtract 27 from both sides. 3x squared equals negative 27. Divide by 3x squared equals negative 9. X is then plus or minus the square root of negative 9, which is the square root of negative 1 times 3 times 3. That will come out as I. That will come out as 3 plus or minus 3i. Again, I have no b term, so 2x squared equals negative 24. Divide by 2, x squared equals negative 12. X, when I take the square root of negative 12, that's the square root of negative 1 times 2 times 2 times 3, which is 2I radical 3, plus or minus. And then finally, one with a b term. I would use the quadratic formula. So x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we're looking at 8 plus or minus the square root of 64 minus 4 times 5 is 20 times 4 is 80 over 10. 8 plus or minus the square root of negative 16 over 10. Up here we have a little more room. 8 plus or minus radical 16 is 4i for the negative. I can factor out a 2 from everything, so that gives me 4 plus or minus 2i over 5. This is typically a recognizable solution. Sometimes you might be asked to record them separately, in which case it would be 4 plus or minus, not the minus, let's erase that last guy. 4 plus the square root of 2i, 4 plus 2i over 5, or 4 minus 2i over 5. Either way, depending on the way that your program wants you to record your answers, I think MathXL might ask you to do it the second way, separated with a comma. Thanks for listening, and I'll see you in class.